Welcome to a new test and teardown video. This time it's another power supply from Hewlet Packard. This one is called E3630 and it's a triple output DC power supply. And it's in a very good condition considering its age. I think this one is from 1996 or something, because I've been trying to Google a little bit around, and in the flyers they send out in the catalogs from 96, I find exactly this model. If it's older than this, please correct me if you have any older material, and also in this catalog you find a very nice description of the other models. So there's also a 3620, and that is only two outputs. It's actually just the same as this one, just without the 6 volts, so it's still positive and negative tracked and all that kind of stuff like this one. And then they got all the single supplies in the same sexy case size. This is a modern size for modern equipment, so this will fit together with all my modern equipment, so that is absolutely great. And all the single supplies, they also called E36 and then 10 to 17. And then you select all the different voltages and current ranges you need. However, all the single supplies, they offer, of course, current, constant current, and current protection variable and all that kind of stuff. There's of course not room for this on this unit. And also the single supplies, they offer a 10-turn potentiometer. That is of course too expensive to have on this model. Yes, I was about to tell you about this tracking ratio. So the plus minus 20 volts, they are of course share the same common ground or return as the positive 6 volts. So here we got positive and negative 20 volts with the same common. So that means it's not three completely individual power supplies. You can't parallel or series them. They all reference to the same common ground. So here you adjust, of course, let's just turn it on and show you guys this. So here we are now in the 20 volt. The meter is now connected to the 20 volt. That's what I'm trying to say. So here we adjust the 20 volts. So if we adjust this to exactly 20, that was lucky. So this is the tracking ratio. That is a little bit funny thing. So if I put this into fixed, click, that means the positive tracks the negative, or the negative is obviously controlled by the positive. So now the negative tracks to the positive. So let's switch the meter to the negative, and it's also negative 20. So if I put the tracking ratio to about half, okay. If I put it at exactly half, right? So now my tracking ratio is 50% off my positive. Now I go back to my positive. So this is 20. What happens if I put this down to 10? Well, we are going to play with easy numbers today. So around 10. And then my negative is about 5. So it is quite easy to use. It's just a funny way of thinking about how you adjust a positive and negative supply. I mean, I have never in my 40 years of experience with designing electronics and using positive and negative supplies, I mean, I've never needed a power supply that can do unsymmetric in one unit like this. I mean, I would definitely just take two separate power supplies, but this is just a funny feature that I will never ever use. It will always be in the fixed, and I always want a symmetric power supply for my analog circuits and stuff like that. It is so funny. And of course, I was actually trying to tell you guys that I really didn't like this single turn potmeter because it's not so easy to set up the correct voltage. However, I think today I've been super lucky about it is actually possible. You see, if you got a very steady hand, and if you support it to something while you're turning, I mean, you can definitely set up the voltages super accurate with a single turn potmeter. One of the things that I came here for was actually to upgrade it for a multi-turn. So I'll see if I can find space for this, and let's see if the voltmeter is really that accurate. Yeah, it's sort of accurate enough for most people. And let's check out the negative supply here on the display. It says 9.8. Yeah, it's of course tracking the positive perfectly fine. It's only in the readout, so that's great. Let's look a little bit at the block diagram. It's a full linear power supply, so I expect this to be super silent. It is a little bit special when it comes to the 6-volt output, because the 6-volt output, well, the voltage control and the current control is very normal. They are ORed together into the driver stage, and all that is completely normal. But as you can see here, there is a fold back current limit, and this is of course because this thing is able to give 2.5 amp into 6 volts, and its heatsink is very small. So if you short circuit this, you will have all the voltage over your series regulator, and with 2.5 amp, it's of course going to overheat the transistor. So that is why there is a foldback, and the foldback goes to 1 amp. And they even deliver a nice schematic about how this foldback works, and even the tolerances and all that kind of stuff. A classic HP to do it super duper nice. Also in the block diagram, you see something that is a little bit funny. The positive and the negative 20-volt system, there is a pre-regulator. So what exactly is that pre-regulator? I look forward to open the unit and see if I can figure out what exactly is a pre-regulator. I haven't been able to find a schematic. I've been able to find some service manuals with component placements and all sorts of stuff, but I didn't find a schematic. So far I have no full explain about this pre-regulator, what that is. Oh, before we open, there's one more thing. If you see my my power supply connectors here, the banana connectors, you would see that they're definitely not original. I've been searching around the internet and I cannot find one single power supply that looks exactly like mine. So that tells me that somebody modified those connectors. And it is a little bit annoying because 2 of them, they're black. And originally the right one was supposed to be green. Of course, because it's earth or chassis protection. So you can use this to protect yourself or whatever circuit you're playing around with. So I went up to my little storage and look what I found. Exactly the right model and type in the correct color. So I'm going to change this into the correct colors. That is going to be so much easier for me in my daily work not to mix this up. It should have been like this from the first place, right? So now I'm about to open it and I can reveal that you find no screws. This is of course the more modern approach. Let's make it faster and make it cheaper. So everything here is optimized a little bit for a super smart production, and that is of course a good idea. So you need to open this with a flat screwdriver and do like this, clickety click, and then you will be able to open it. So this is super easy to open. However, look at that. This one was checked for safety back in '96. So this reveals that yes, this unit is from 96, or probably a year older than this, right? So people would only send it in for checks 1 year after they purchased, I guess. I mean, at least this is my guess. I really look forward to see the type numbers or any date codes inside. And here it is, the voltage selection. It is written here on the outside, so that's super easy to figure out. So this is the inside look, and see what I find. 94. I also find 94 on many of the ICs. Some of the transistors there from also 94, 92. So yeah, I'm definitely sure about this unit is from 94. So far so good, right? So of course there is a super big and beefy mains transformer in here. It's very difficult to see, but look at that, 1 million tappings. Well, maybe not 1 million, but quite a lot. And that is because we got 3 output voltages, and we also got some auxiliary voltages. Well, of course, this is the 6 volt output in this section here, and the beefy rectifier here is for the 6 volts, and that transistor is also for the 6 volt. And yeah, we got some auxiliary voltage regulators for all that kind of stuff. Fantastic. And remember, I talked about in the block diagram about the pre-regulators. I'll come back to that in a second. Here you see the output transistors, NPN and PNP, for the positive and negative. See, it's tip 35 and the other one is a 36. I'm sure I can show you this. Yes, exactly. They're also used in audio amplifiers, by the way. So there's a little bit of a funny little aluminium screw, those 2 transistors to this and then up to the heatsink. But I think that is because this heatsink is of course the same heatsink used in all the different models, and here the distance between those 2 screws is of course this distance. So in many of the other models you'll have another TO3 mounted here, but since we need those 3 outputs, we need 3 transistors, 1, 2, 3, and this is why they made this little aluminium adapter here. They could have, of course, taken the transistors with a little bit longer leads and then or bend it back like that, but as you can see here, half of the transistors would then be outside, and now that looks like hobby solutions. So that is why this little piece of metal was made. But there is a thermal transition more, and then there's also this thin, well, it's 3 millimeters thicker or so, but it's only a half an amp, 2 times of course, and 2 times 20 volts and all that kind of stuff, but it doesn't really get warm. And why is this not warm? That is because of the pre-regulators. And here is the super cool thing they've done. I don't know if you can see this, but we got some active rectification going on here. We got those 4 optocouplers controlling transistors, and they're actually calling this rectifiers, but this is active rectification, and it is controlled by this op amp, and this is so they're turning on and off in time, so they will pre-regulate the voltages for the output stage, and this way there isn't any heat lost in the output. So it's like a mains frequency operated switch mode pre-regulator. I love it. And you don't even see any coils or anything because they got plenty of induction in the transformer. So it's just a time kind of thing. Lovely idea. And I'm super sad that I don't have a schematic to explain this in super detail, but I think you get the idea how this is done. And the rest here is just normal op amps and blah blah blah. This is how it's always done. But look at that. Riva. This lovely component needs to go. And there's actually even maybe a crack. Oh, yes there is. Can you find a reefer that is nearly, well, very close to 30 years old without cracks? Nah, probably not. So those are going. There's only one of the nasty reefer. Here you have the LED readout. They're using some display driver chips. I can't really. Yeah, I think I've seen those before. And it's of course multiplexed. Nah, I'm not super happy about that. Probably this is going to make a little bit of noise, but it's not directly connected to the output like that. So they're probably filtering stuff. And it's probably not a big deal. And here is my one-turn potmeters. I don't care a lot about the 0 to 6 volts because that should be fairly easy to adjust. But this one I do care about. That could be cool to change into a 10-turn. And if I'm not mistaken, they're using 10Ks because they kind of always do that. Can we see if that is a fact or not? Let's get some. Why can't I see that? Yes, come. Focus you. 10K. So I think I got those stocked. And then there's of course this funny tracking with a switch. I leave that. I don't care so much about that. And then I have to change the banana on my chassis. That is gotta be the correct. Fascinating. You can go this far without removing one single screw. That is great. So now I was about ready to remove the reefer, but I was just doing a quick inspection. It's always fun to see if there's any funny stuff around the PCBs. Is it super clean? What have you got? And then what do I see here? What's that? A little oopsie doopsie. And see, it is actually stuck into the flux. So this was left here when somebody soldered those wires. They did not see what they were doing, and they were cutting probably this or that, some of these, and then left this little piece in the flux. That is not a good quality sign, by the way. So that looks a lot better with the correct banana plug. So now I'm trying to change the potentiometer to a 10-turn, and that was of course super easy to find a 10-turn in my box of pot meters and stuff. But there's a little problem with the shaft, as you can see here. There's a little no, but this is 6.3 millimeters, and it's the same here. So that's a 1/4 inch, very normal for American kind of designed equipment. They will of course use that. And this knob is definitely made for that shaft. So I got an idea. I'm just going to make it work, right? Anyway, there's another little detail here about the potmeter. So those two are connected together. So that is of course the lever and the end, and that is the other end. So that is the white blue and the white yellow. So this is important to have this noted so I can do it right. So it turns out the numbers on those potmeters, see, 1, 2, 3, is always the same. And that means when it's like this, when you turn down the voltage, you short circuit the, you get 0 ohms, right? So that is the same here in this one, the center here. So it's 2 and 3, so that's the same. I think it turned out pretty well with the filing here. So this is brass, super easy to file in. I'm a little bit sad about the little dots I made here to hold the shaft, so I had to clean them a little bit. That's a shame when I really filed it so beautiful. I think that went quite all right. Yeah, you have to cut this little top plastic thing. It was like this to support the potentiometer from turning around, but you have to remove that. But then it will fit quite all right. I could actually also fit one in the other one, but I don't really care about that because it's the 6 volts output, so who cares. And then yeah, all I have to do now is find a new capacitor for the reefer thingy and then put it back together. I've been playing around with this power supply a little bit now that it's completely assembled and all that. And I'm really happy about it. Damn, it is nice. And then I come to this step load response. Here is a funny thing that happens in my test setup. And let's try and see if we can figure out exactly why this happens. So here's 50 millivolts per division. And this is in AC modes. And of course, when I release the load, then I get this. But what is that nasty stuff here going on here? So my test setup is the power supply is connected to my DC load. I turn on the load. I'm loading it very close to full potential. Then I click single, and then I hit the on-off switch on my electronic load, and then I see this oscillation kind of funky stuff here, right? So 40. See, here's the trick with an electronic load. It will tell you the resistance that you need to recreate this scenario, right? So 41 ohms is what I need. All right, I'll try and do this with resistors and see if I see the same kind of thing. I am sad to say this oscillation phenomenon that we see is definitely coming from the power supply. Look at that. So there's some sort of an unstable time after a full load. I just recreated this whole thing with resistors. That's my resistor load thingy. All you have to do is connect my resistors, and you see the same kind of current. Dabba-doo. And then I pull the plug, and see, here we go, the same shit. So there is an unstable phase. Oh, that is bad. Why would it do that? It says high frequency oscillations and stuff. Yeah, so I think I revealed a design fault in this unit. It's supposed to be this nice and clean. Obviously, you're gonna get the step response. That is totally accepted, but this I don't like at all. Why is this happening? Well, that's just how it is. I think I will end this video now and tell you that that power supply is not that 100% perfect. And I mean, it's HP. It's supposed to be perfect. You're paying big dollars for this kind of stuff. Well, what is that? No. And I even put my... Let's try and give it full. Let's try and do it again and see. Single, and oops. Whoa. You see what I'm saying? This is high frequency nasty stuff. Let's do it again. Oops. trigger problem. Yep, you see? This is badass. So this is now 200 millivolts per division. And this is nearly full load. And this is the step response in here. This tiny little bit. Self-oscillation. And then... No way. Better luck next time, HP. Yeah, well. The disappointments, they are completely gone on the 6 volt output. I put it into 5 volt mode and I adjusted my load for 2 amps. So I'm doing an on-off load from 2 amps to 0. So that is 2 amps and then 0, splat. And look at that, it's only 40 something millivolts, and this is gone in 2 milliseconds. And this is of course completely accepted. I think we could probably do the same like that when I enable the load. Obviously the voltage is gonna drop like this. Completely perfectly fine. So that output is nice and stable. Could be fun and see if the negative 20 is also the same. Oh, this is actually a little bit funny. So the negative supply don't do this at all. It is nice and stable and it's doing exactly what it is supposed to do. So maybe I got something funny going on in this power supply. That is interesting.